Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to look at some definitions to do with complex numbers and things that you will need for further maths to help you get through complex numbers, de Moivre's theorem and roots of unity. So to start with, we're going to look at the basic definition of a complex number. So if I've got the point xy, means I go across x and I come up y to this point xy. The length of this line here we're going to call r, and the angle it's rotated by we're going to call theta. So the complex number z is equal to x plus iy because we're in the complex plane, so we've got x across and we're coming up iy, so we're looking at complex numbers. So this is like my I component up here in the imaginary axis. So I've got my real axis down here and my imaginary axis up here. Now from here I can use this to work out the length of r. So the length of r is the magnitude of z, written like this. So this means the magnitude of z is equal to the length of r. And to find the length of r, we can use Pythagoras. So we can use x squared plus y squared square rooted gives me the length of z, or the length of r, the modulus of z. To work out the argument, we have got this is the opposite, this is the adjacent. So to find the argument of z, the angle theta is tan to the minus 1 of y over x. Now just be careful of using this because sometimes it won't always work, because if you've got a negative number in there, sometimes you're in the wrong quadrant, so you need to check the position of your x and y before you work this out. Otherwise you'll have to use the definition of x and y to find it. So just check where this coordinate is. If it's in the positive top right hand quadrant, then it will be tan to the minus 1 of y over x. Now this distance here using trigonometry, this side here is the adjacent. So because it is the adjacent, this is my hypotenuse. This side here becomes r cos theta. So if you use normal right angle trig, you've got your hypotenuse and your adjacent. So cos of the angle is the adjacent divided by the hypotenuse. So to work out the adjacent, it's going to be the hypotenuse times by the cos of the angle, which is r cos theta. Similarly, we can do a similar thing here to do with trigonometry, and this vertical distance here, instead of writing y, we've got the opposite and the hypotenuse. So you should know that sine theta is the opposite divided by the hypotenuse. So to work out the opposite, we have to do r sine theta. So it's the hypotenuse times the sine of the angle. Once we've got these two things here, I can replace x with r cos theta and I can replace y with r sine theta. So I've got z is equal to r cos theta plus ir sine theta. Now both of these terms have got an r common, so I'm going to factorise out an r and I'm going to write it in modulus argument form. So by taking a factor of r out, I've got z is equal to r cos theta plus I sine theta. And your answer will be written in modulus argument form. So in the exam, they will use this word saying leave your answer in modulus argument form. It means write your answer like this. Now there are alternative ways of writing your answer in modulus argument form. This is one method. Alternately, you can shorten the cos theta plus the I sine theta to cis. So you've got the cos. So C stands for the cos, the I stands for the imaginary part, and the S stands for the sine, so it can be written as r cis theta. It can also be written as r comma theta. So all these are modulus argument form and they mean exactly the same, but you need to be able to interpret all of these and understand they mean exactly the same, and don't get confused as to which way you write your answer. It's personal preference as to which form you like to work with. Now we can also write z in exponential form. Now you need to remember Euler's formula. Now there is a proof of this using Taylor's series, but that is not on the syllabus, so I'm just going to tell you that Euler's formula is e to the I theta is equal to cos theta plus I sine theta. So you'll be expected to use Euler's formula. So in here I've got a cos theta plus an I sine theta, so instead of writing this section, I can write it as z is equal to r e to the I theta. So this is the exponential form of the same thing. All different ways to write how to get to this point here, p, of the complex number. So there are multiple ways, and you need to be familiar with all of these to make sure you understand what we're going to do. So we're going to look at these, and we're going to link this into the nth root of unity shortly. So we're going to look at the nth roots of unity. So basically the nth roots of unity are the solutions to the equation z to the n equals 1. So if you've got something of this form and you find the solutions or the roots, then that is what you're doing, finding the nth roots of unity. So we're going to look at how to do that using a formula and what it means diagrammatically and different notation linked to this. So key facts that we've already talked about was the complex number z is equal to x plus iy. So we can write it in modulus argument form or exponential form. The magnitude of z is the length of r, which is using Pythagoras of the square root of x squared plus y squared, and the argument is tan to the minus 1 of y over x. Now, de Moivre's theorem you'll be expected to know, but it is given in the formula book on multiple different exam boards, so check your exam board so you know exactly what is given on your exam board. So r times by cos theta plus I sine theta all to the power of n is the same as r to the power of n, so just bringing this first term to the power of n. And then the second part, de Moivre's theorem says that the n can come in front of a theta, so it becomes cos n theta plus I sine n theta. So that is what de Moivre's theorem says. So this n can be replaced in here as n theta and sine n theta. So this is de Moivre's theorem, and it will be given to you in the exam in your formula book. Now, the roots of unity formula is also given in your formula book, and you'll be expected to know that the roots of z to the n equals 1 are given by z equals e to the 2 pi ki over n for the values of k equal to 0, 1, 2, all the way up to n minus 1. So this will be given in your formula book as well, but check for your exam board that you know what is given and how it's written so you know what to expect in the exam. So we're going to have a look at solving z cubed is equal to 1, and we're going to look at finding the nth root of unity for this z cubed equals 1. And specifically for this case, we're going to be finding the cube roots of unity because we have got z cubed. So using the formula book, it says that n is equal to 3 because I've got z cubed, so n is equal to 3. So over here it says for k is equal to 0, 1, 2, all the way up to n minus 1. Now here n is 3 because I've got z cubed. So 3 take away 1 is 2, so it's going to be for 0, 1 and 2. So these are the values of k. So I'm going to stick these values into this formula here. So I'm going to get for k equals 0, I've got e to the 2 pi 0 I divided by n, and n is equal to 3. So I've got e to the 2 pi times by 0 I over 3. Now anything times by 0 is just going to give you 0, and e to the power of 0, or any number to the power of 0, is always 1. So my first solution is 1. When I put 1 in, I'm going to do a similar thing for k equals 1. So I'm going to replace this 0 with a 1. So I've got 2 pi times by 1i over 3. So we've got to write this using this form here in order to work out the answer. So we've got 2 pi by 3, so I can replace theta with 2 pi by 3. So that's the same as cos of 2 pi by 3 plus I sine of 2 pi by 3. Now on your calculator, make sure you are in radians, so there's a little R at the top of your calculator. And if you type in the value of cos of 2 pi by 3 and work out the value of sine of 2 pi by 3, you will find that cos of 2 pi by 3 is minus a half. Sine of 2 pi by 3 is root 3 over 2. So that is the same as minus a half plus root 3 over 2 lots of I. Now for k is equal to 2, we can work out our third solution. So our first one was z1, our second is z2, our third is z3. I've got e to the 2 pi times by 2i over 3. And again, I've got 2 times 2, which is 4. So writing it in the form, in modulus argument form, I've got cos of 4 pi over 3 plus I sine of 4 pi over 3. Typing this in your calculator is going to give you minus a half, and typing in sine of 4 pi by 3 will give you minus root 3 over 2. So these are my roots. So this is the answer to the nth roots of unity. Now we can draw these roots on an Argand diagram. So remember, we have our real and our imaginary. So our real going across in the horizontal axis. When we're plotting this one, we go across minus a half, so to the left minus a half, and then we're going to go up root 3 over 2. So for my first one, I've said here, I go across to the point here, 1. The next one, I go across minus a half up root 3 over 2. The last one is minus a half minus root 3 over 2. And you can see that these have been equally spaced out on the diagram. So you will find the patterns that appear when you've got roots of unity, they will always have a nice symmetry to them. So they are all equally spaced going around. So if you had the fourth root of unity, then it would be on each of the axes going along here. Now we know that the angle is 2 pi by 3 because you can see in here I've got 2 pi by 3. So that is the angle in between each of these. Now the solutions are Z1, Z2 and Z3. So I've got 3 different solutions coming out here. But we can use some different notation. So I can say that this first one here is 1. And if I call my second one, so the answer I've got here, cos of 2 pi by 3 plus I sine of 2 pi by 3, if I call that omega, if I multiply 1 by omega, it takes me to this root here. If I multiply this answer Z2 by omega, so multiply by omega again, it will take me to Z3. So if you look here, the notation is omega squared. So if I take the answer I had for omega, which is this here, and I square it for omega squared, I can now use de Moivre's theorem, so the 2 and the 2 can come next to each other, giving me 4 pi by 3, and again 2 times 2 is the 4 pi by 3, which is the same as what I've written over here, and that is minus a half minus the I root 3 over 2. So using de Moivre's, it's an alternative way of writing, instead of writing Z1, Z2, Z3 for the solutions, I can call my second solution omega and my third solution omega squared. Alternative notation for that is saying that instead of omega squared, I can say it's an omega with a subscript of the 2, so omega 2. So it means exactly the same. But basically, if you start off with your first root here, and then multiply it by omega, it takes you to the next one. Multiply this answer by omega, it takes you to here. And if you multiply this one by omega, it takes you back to the start, and it keeps going in a loop. So you need to be familiar with this notation here. Next, we're going to look at what happens with this notation and looking at the sum of the roots of these unity so we can see what happens next. So you can see we've still got the same Argand diagram, and I've got the roots of 1 omega, which is up here, and omega 2, which is the same as omega squared, so it means exactly the same, just different notation. Now if I take all these roots and I add them together, so I'm looking at the sum of the roots, if I put all these roots together and I add them together, I've got 1 minus a half, which is going to be 0. And I've got an I root 3 over 2 minus an I root 3 over 2, and they cancel out to give me 0. So the sum of any roots is always equal to 0. Now I can write this in terms of omega, so 1 plus omega squared plus all the way up to omega n minus 1 will equal 0. So if you add together all these different roots, they will always equal 0. Similarly, I could use the other notation. So I've got 1 plus omega 2 plus all the way up to omega n minus 1 is equal to 0. So this using the subscript notation as well as the superscript notation. So they mean exactly the same, and they are just showing that the sum of the roots is equal to 0. Now, normally in the exam, the letters that are used are either Z or omega, but other letters can be thrown in there to confuse you. So it just means exactly the same. So don't be put off if you see different letters to what you're used to seeing in the textbook. Now we're going to look at an exam question using what we've just looked at with the notation using the omega and seeing what happens with these roots. So you're given a complex number omega, which is cos of 2 pi by 5 plus I sine of 2 pi by 5, and the equation z to the 5 equals 1. So when you look at that first bit of information, you should be thinking the roots of unity, thinking about all the facts that we've just said so far. So I'm going to get those facts written down so you can visualize them, and you should be thinking this in your head. If you need to write some of them down as you're going through the exam paper, then feel free to write them down when you need them. So key bit of information, make sure you highlight it in the question. You can write on the exam papers. Okay, these two first bits of information are really important. Now part A says show that omega is a root. Okay, so you've got to show something as a root. And remember, whenever you're trying to find anything as a root, basically the answer is going to be 0 when you substitute it in. So your key facts. As I said, De Moivre's theorem, it's in the formula book. You'll be expected to be able to use De Moivre's theorem that is given to you. The roots of unity formula that we've just looked at is also in the formula book, so you make sure you know how to use that roots of unity formula. The sums of a root you'll be expected to know, so I've just written it in terms of omega squared this time, so omega cubed, etc. all add up to 0. And if you look later on in this question, we've got an omega plus 1 over omega. You should be familiar when you see something like that, z plus 1 over z is equal to 2 cos theta. So you should be familiar with that. So we're going to start off with z to the 5 is equal to 1. So we're going to show that this is a root to the equation. So instead of writing, because we've got omega, we've got to show that this is a root, we're going to replace the z with omega. So I've got omega to the 5 is equal to 1. So substituting in, I've got cos 2 pi by 5 is equal to I sine 2 pi by 5 all to the power of 5. Now using De Moivre's theorem here, this 5 from up here can come in front of the theta. So instead of having theta, I've got n theta, or in this case 5 theta. So this 5 is going to come in front of the term here for after the cos theta and the sine theta. So I've got cos of 5 times 2 pi by 5 plus I sine of 5 times 2 pi by 5 is equal to 1. Here I'm just going to simplify. So the 5's cancel, leaving me with 2 pi, and the 5's here cancel, leaving me with 2 pi. So I've got cos of 2 pi plus I sine of 2 pi. Again, check your calculator is in radians, so there's a little r at the top. And if you type in cos of 2 pi on your calculator, you'll find you get the answer of 1. And if you type in sine of 2 pi on your calculator, you'll get the answer of 0. So 1 plus 0, I is equal to 1. Therefore, you have shown that this is a root because the answer has come through to give you 1 is equal to 1. So you have shown that this fits into this equation, so it is the root. So well done if you got that correct. Now the mark schema for this, the DR means direct reasoning. So basically means you must show your working out at A level to get the marks. So M1 is a method mark, so you will get a method mark for substituting this omega into the equation and solving to show that the answer is equal to 1. The AG just means that it was a show that question for the examiner. And you can see there are 2 marks here. So this is where your marks were awarded, one for substituting in, one showing it comes through to the answer. Give yourself a big tick if you got that correct. You've done really well. Now, part B, we're going to look at the other 4 roots of the equation. And feel free to pause this video at any point to write down key facts or to have a go at doing the question before I go through the answer. So writing out the 4 roots of the equation. So we have already looked here. You can see these are the roots. If you add the sum of the roots, you get 0. So it's not a trick question. It's only worth 1 mark. So our first root is always going to be 1. So there's my first root here. So omega is already given here. You're told that's a root, so that we don't need to write that one down. So the other roots, the next root is going to be omega squared. And then the one after that will be omega cubed. And then omega to the 4. So I've got 1, 2, 3, 4 roots. And that's all you had to write down for the 1 mark. So you can see here the mark scheme just shows the next root. So they've just multiplied each omega by omega, the first omega by omega to give you omega squared. omega cubed to find the next one, multiply by omega again to give you omega to the 4, and then you've got 1, which is the initial root, which is the same as omega to the 5. Or you could have done it over here using the roots of cos 2k pi over 5 for k equals 2, 3, 4 and 1, or equivalent to 5. Give yourself a big tick if you got that correct. You've done really well on part B. Now on part C, you've got to show that omega plus omega squared plus omega cubed plus omega to the 4 is equal to -1 for 2 marks. Now, you should look at that and think this is pretty obvious, okay? Because if you look over here, this is very similar to what we've got here. The sum of the roots is going to equal 0. We know that the sum of the roots equals 0, but it's showing that, which is more difficult, okay? So to start with, we know that if I take all these roots here, so 1 plus omega squared plus omega cubed plus omega to the 4, we know the sum of those are 0, but we've got to show it, okay? So we're going to look at this sum of this series here, and we're going to look at this, and this is a GP series, so this is a geometric series. So we know it's a geometric because each term is multiplying by omega, so it's got a common ratio between each term rather than a common difference. So my first term is going to be A, and my second term, or my common ratio, is going to be my second term divided by my first term, so omega divided by 1 is going to be omega. So we have got a GP with an A of 1 and R of equal to omega. Now in your formula book for A-level maths, it's got S of n is equal to A, 1 minus R to the n divided by 1 minus R. So this is an A-level formula, not a further maths formula, but you'll be expected to know and use, so you can look it up in your formula book and use this formula. So we're going to replace the A's with the 1, the R with the omega, and the n is going to be a 5 because we have got 5 terms here. So 1, 2, 3, 4, 5. So we're finding S of 5. So from here, we have got to put the values into the formula. But we know at the top that Z to the 5 is equal to 1. So if Z to the 5 is equal to 1, that means omega to the 5 is equal to 1. So I can substitute that into here, leaving me in my numerator being 1 take away 1. And we know 1 take away 1 is going to equal 0. So S of 5 is equal to 0, which means the sum of these 5 terms here is equal to 0. So there's my proof that all these terms added together equals 0. So we want omega plus omega squared plus omega cubed plus omega to the 4. So these terms here, if I get rid of this plus 1 and subtract it, gives me what we're trying to show. So therefore we've shown for 2 marks. Tricky question, so make sure you understand what you're being asked to do, because it has required some A-level knowledge here in order to be able to answer this question. The mark scheme on this question shows alternative ways different to what I've shown you how to do it. It is personal preference as to which method that you want to use. So the one similar to what I've done is by looking at the sum of the roots, which is a further maths topic in year 12. So using minus b over a. And then looking at the coefficients. They've done it in different ways here. As long as you can show with a valid reason and your method, you will get the marks in the exam. And AG just means it is a show that question. Give yourself a big tick if you got that correct. Well done. Now in part D, we're going to be looking at showing that omega plus 1 over omega all squared plus omega plus 1 over omega minus 1 is equal to 0. And you might be thinking, okay, I can use this in here. It might help you. But this question, because you're just trying to show it all equals to 0, we're not actually going to use this part just yet. Okay, so don't make it harder than you need to do. All you're going to do is use the definitions of what we've got here. So we're going to expand the brackets. So this is omega plus 1 over omega times by omega plus 1 over omega. So when you expand the brackets, you've got omega times omega is omega squared. Omega times 1 over omega is going to cancel to give you 1. And then when you do it again the other way, you've got another 1. So 1 plus 1 is 2. 1 over omega times by 1 over omega is going to give me the 1 over omega squared. So I've got an omega squared plus 2 plus 1 over omega squared. This term stays the same, omega plus 1 over omega minus 1. So I'm just looking at the left-hand side of this expression here. Now, if you want to pause the video at any point to try and get ahead and see if you can work out how to do it, now I've given you a little hint, feel free to have a go before I go through the rest of the answer. Now from here, we have got lots of different omegas and they're all at different powers and different levels. So we're going to start and put them in descending order, starting with the highest power. So I've got an omega squared here. The next highest power is an omega. Then the numbers come next. So 2 take away 1 is 1. Then I've got the 1 over omega and then the 1 over omega squared last. So I've just put them in descending order and simplified my 2 take away 1 in the middle. Now, we don't like this fraction here, so we're going to take out a factor of 1 over omega squared. So when I take out a 1 over omega squared, if I take it out of this term here, if you've got something divided by omega squared, what is that term? So it has to be omega to the 4. So we're going to factorize it. So I've got omega to the 4 divided by omega squared gives me omega squared. Omega cubed divided by omega squared gives me the omega. Omega squared divided by omega squared is the 1. Omega divided by omega squared gives me 1 over omega. And 1 times by 1 over omega squared is 1 over omega squared. So this gives me an expression now in terms of omega. And I've just highlighted these 4 terms here, the omega to the 4 plus the omega to the cubed plus omega squared plus omega, because that is what we have got in part C. Now this question said hence at the beginning. So as soon as they say hence, it means use the answer to what you've already worked out. So this answer here, all these terms here added together gives me an answer of minus 1. So that means all these terms here added together gives me an answer of minus 1. So I've got negative 1 take away 1, which is going to be 0. So anything times by 0 is 0. So therefore it is equal to 0. So I've shown it. So just beware when it says the word hence, use the answer you've already worked out. Give yourself a big tick if you got that correct. You've done really well. Now the mark scheme has shown 2 different methods to be able to answer this question, each for 3 marks. So you can see clearly where the 3 marks are awarded using the top method or the alternative method down here. It is your preference as to which way round you do it. Personally, I think the top method is easier, where you're just expanding out the brackets, which is what we've done at the top, and then substituted in. This one here works backwards, which I think is much harder to do, but it is personal preference as to which way round you like to do it. Now part E is also a hence question. So it says hence determine the value of 2 pi by 5 in the form a plus b root c, and you've got to work out the values of a, b and c, and you're told they are rational numbers to be found. Remember, a rational number is just a number. Any number that isn't just keeps recurring. So it's just a whole number, could be written, number written as a fraction is a rational number. So to start with, we're going to be looking at this fact here, z plus 1 over z is equal to 2 cos theta. So we are using that fact now that we had earlier, and we're going to be substituting that into this expression here. So we've got z plus 1 over z is equal to 2 cos theta. So we're going to say that omega plus 1 over omega is equal to 2 cos of 2 pi by 5, because omega is equal to cos of 2 pi by 5 plus I sine of 2 pi by 5. So I can use this formula over here to work this part out. So from here, I'm going to substitute in. So I've got 2 cos of 2 pi by 5 all squared, plus 2 cos of 2 pi by 5 minus 1 is equal to 0. From here, we're going to rearrange this. Okay, so I'm going to do the 2 squared, which is going to give me 4. So I've got 4 lots of cos 2 pi by 5 plus 2 cos of 2 pi by 5 minus 1 is equal to 0. Now you should spot that this is a quadratic. So you can see here I've got my squared term, my number term or my x term, and my constant is in the form of a quadratic where x is equal to cos of 2 pi by 5. So using your quadratic, you can use your calculator to use the quadratic formula. So a, which is the coefficient of the first part, is going to be 4. B is the coefficient of the middle term, which is going to be 2, and C is the value on the end, which is -1. You're going to substitute those values into your calculator to get the answer of cos of 2 pi by 5, which is going to be -1 plus or minus the square root of root 5, or square root of 5 over 4. Now we need to check which of these answers is right, because we've got a positive answer and we've got a negative answer. So if we work out cos to the -1 of this, the answer should be 2 pi by 5. So we're going to check that out. So we're going to look at cos to the -1 of -1 plus root 5 over 4. The answer is 2 pi by 5. But let's see what happens when I put a minus in there. So if I do cos to the -1 of -1 minus root 5 over 4, I get the answer of 4 pi by 5. And we want the answer of 2 pi by 5. So they want the solution to cos of 2 pi by 5. So they want this one here, this first answer here, and you've got to work out the values of A, B, and C. So your answer is cos of 2 pi by 5 is equal to -1/4 plus root 5 over 4, where A is this first term here, -1/4. B is the number here, so it's going to be the quarter. And the C is the number under the root, which is going to be 5. So this is your solution. Give yourself a big tick if you got that correct. You've done really well. Some tricky stuff on there, so well done if you managed to get that correct. It was worth 4 marks in the exam. The mark scheme on this question shows where the 4 marks were awarded. So here are the 4 marks. So B1 and N1 are just method marks, showing you where your marks were awarded. So for realising that omega plus 1 over omega is 2, cos 2 pi by 5 is 1 mark. Then for coming down to your quadratic is your second. Then for spotting, it is the correct solution. And equating them to make sure that I've got another method mark, and finally getting your answer mark of the -1/4 plus root 5 over 4 and stating the values of A, B and C. Sometimes it doesn't say you have to state what A, B and C are, but it is worth doing it if the question does ask, because you could lose marks if you don't. If you found this video useful, please share, like and subscribe so we can all get great at maths. If you've enjoyed this video, please don't forget to share, like and subscribe. Please follow Get Great at Maths on TikTok, Instagram, Facebook and X. What do you want to see next on Get Great at Maths? Please comment below. See you next time.